Join the 321 Science team as we investigate what gravity is and how it plays a role in our solar system and on the OSIRIS-REx mission. Gravity is a force of attraction that exists between any two objects with mass. Sir Isaac Newton, the 17th century physicist, discovered that gravity is not only the force that caused the fateful apple to fall, but that it's also the force that is responsible for keeping the moon in orbit around the Earth, for keeping the Earth in orbit around the Sun, and keeping us from floating off the surface into space. Gravity affects every object near Earth, but interestingly, it does not affect them with the same strength. Gravity's strength between any two objects is dependent on the mass of each of the objects and the distance by which they are separated. Gravitational force follows an inverse square law, meaning that the strength of the force decreases as the square of the distance increases. So what's gravity like on an asteroid like Bennu? Bennu's mass is about 80 billion kilograms. You'd have to add almost 14 more zeros to get to the value of Earth's mass. When talking about the speed at which an object needs to move to break free of a gravity field, we use the term escape velocity. Although it takes the power of a rocket to blast off of the Earth's surface, the escape velocity of Bennu's surface is so small that a human could easily jump off of Bennu and into space. Understanding Bennu's gravitational environment will come in handy when our OSIRIS-REx spacecraft is ready to head for Bennu. Bennu orbits the Sun at a different inclination or angle than the Earth. After launch, our spacecraft will fly by the Earth using the Earth's gravity to make an inclination change before continuing on its way toward Bennu. This is called a gravity assist, a technique that is used a lot in planetary missions. By using an object's gravity to change the trajectory of a spacecraft, we reduce the amount of fuel that the spacecraft needs to complete its mission. When you talk about gravity, you also need to talk about how far out into space a body's gravitational field extends. Theoretically, a body's gravitational field extends infinitely into space. The area around a body in which its gravitational influence is more dominant than other bodies is called the Hill sphere. Earth's sphere of influence extends out to almost 1 million kilometers. For reference, our moon is on average only about 385,000 kilometers from the Earth, so our moon is well within Earth's sphere of influence, which keeps it in orbit around the Earth even though there are more massive objects in the solar system, like the Sun. Something as small as Bennu only has a sphere of influence that extends 20 to 30 kilometers out from its surface. Bennu's small sphere of influence is unique because many mission spacecraft operate around bodies that have a significant gravitational field. OSIRIS-REx, however, will be operating in a microgravitational environment. This means that substantial changes in the OSIRIS-REx trajectory require only small amounts of fuel, which helps OSIRIS-REx to view Bennu from many different locations. Gravity is the key factor in understanding our place in the universe and in knowing how to orbit Bennu and asteroids in the future. For more information on gravity and OSIRIS-REx's spacecraft instruments, click on the links. 321 Science is a partnership with the University of Arizona, NASA Goddard Space Flight Center, and Lockheed Martin.